Welcome. This is question 6. Now we want to repeat what we have done for random forest regressor. We want to do it again using another one type of regression, which is called regressor. So now we are importing, and after that we run the model and use the model to estimate for our data set. So after the estimation, we can now make prediction with it. So the prediction this time around is referred to as reach YP, because it's Y that we are predicting using X, because Y is modeled as a function of X. Now the first part of the prediction we can examine to see which of them is over predicted or under predicted. We want to print the prediction for the head of the data set. So this copy, paste. So we have the first one, 741,000. For us to actually compare, let's bring back the actual data set for Y, test, and compare and see. When we did the random forest regressor, most of the first 5 items were predicted as over predicted. Now this first one now is 815,000 but predicted as 741. That's under prediction. To see the difference between the two, we can use this formula again and compare to see how many of them are over predicted and how many are under predicted. So for example, the first one now is under predicted to the tune of 73,000. So out of the 5, 4 are under predicted. So we'll be able to answer this question now. Then to check the characteristics, or to evaluate how good is the model so that we can compare. So this is mean absolute error. We can run it now since we are using the same notebook without the need to first import it, because we've done it before. So to see the value itself, we call for the variables. So this is 364,000. What we calculated, mean absolute error that was calculated for random forest regressor, if we check it again, let's bring it. The name was random forest regressor. So if we bring it back, so it was 206,000. Y reach is 364, and the lower the error the better. It means random forest regressor perform better based on mean absolute error. Now let's check the mean square error for the reach regressor. Let's examine the value. This is the number is very long, almost 362 billion, because it is square of the error. So if we compare, since the mean absolute is higher, the mean square also will be higher. Now let's check the half square, which said for half, the higher the better. So the half calculated for the reach for the random forest regressor was about 70. We can call it to confirm. RFR, so it was 70, so this is 70.3, but this one is about 37. So R square of 70 is better than R square of 37, because the higher the R square, the better. So this still confirms that random forest regressor perform better than ridge regressor for this model. This doesn't mean this is how it will be all the time. For another set of data, the situation may be reversed. So thank